Yesterday in math, we had started working back in our workbook pages, and we had finished up with using the tiles. Remember, you used the square tiles to show the 4 rows of photos with 3 photos in each row. And we just did that on this blank space. But now what I want you to do is turn to page 132. And if you remember correctly, your tiles probably looked similar to how this is set up. How many rows do they have here?
4.
4 rows. How many pictures in each row?
3.
3 pictures in each row. Okay, so we made an array using those square tiles. They're using rectangles here. You could also use like the round counters to make an array. But look at what they did with this array. So they start out, whoa, too big, Mrs. Loafing. They start out with the 4 rows, 3 in each row. What'd they do down here? They separated it. Did they break it apart into 2 smaller pieces? So for this one, how many rows are there?
4.
How many are in each row?
1.
1. How many rows are over here?
2. 4.
4. How many in each row?
2.
Okay, so thinking about this diagram, here's what I want you to do. Yours are stapled, but I want you to kind of open it up like this so that you can see this picture to help us with this page. Okay? I can't do that on my screen. So I'll make this a little smaller. Maybe I can see some of it. So looking at your page 133, question 1 says, look at picture it. So they're talking about this part right here. Point to picture it on your paper. Okay, this is picture it. How could you multiply, to find the number of photos in the diagram? Do you know what our multiplication sentence would be for this one? How many rows are there?
4.
How many are in each row?
2. 3.
3. How could we use those numbers to write a multiplication equation? What would that look like for here? Raylan?
3 times 4.
Oh, what did we say first?
4.
How many rows?
4.
How many in each row? What are we doing with those 2 numbers? We're multiplying them. Okay, so now look back at the picture. I have to erase that to be able to go back. So looking at this, what could we skip count by? 3s. So skip count with me.
3.
6, 9,
12.
12. 3, 6, 9, 12. So friends, what would 4, we had it written, you have it written, but I had to erase mine. What would 4 times 3 equal?
12.
12. 12 what?
Pictures.
Pictures or photos, right? Okay, now we're looking at the model it for question 2. Point to the model it that they show us. Remember, that's the one that they broke apart. What two numbers was 3 broken into to help solve the problem? So look at the whole thing, because there's 3 in each row. Now look down. So they had 3 in each row. Are there 3 in each row now? No. How many are in this row? 1. And how many are here? 2. So they broke 3 apart into 1 and 2. Let's go back to 2. What 2 numbers was 3 broken into to help solve the problem? 1 and
2.
write it down. What and what?
1 and 2.
Okay. All right, so we just said it was broken into 1 and 2. Now for part 3, number 3, what 2 multiplication equations could you use then for the 2 smaller arrays? So looking at this first array, what would our multiplication equation be? How many rows are there?
1.
How many
4.
rows are there?
4.
4 rows. How many are in the row?
1.
1. There's only 1 here, right? So what would our multiplication equation be for this one? Don't say it out loud. Think about how many rows times how many you have in each one of those rows.
Mrs. Lopi?
Yes.
Hey there. If you wouldn't mind taking a look at the email that I just sent to you, I would appreciate it.
Sure thing.
Thank you so much.
You're welcome. Write down what you believe the equation for that first array is. Okay, what did you put? I'm going to come around and look. How many rows did we say there were here? What would you write for this multiplication equation? You're right so far, but then what? Yes. Okay, and we're starting. All right, good job. Everybody wrote 4
times 1.
4 times 1, because there are 4 rows, whoops, 4 rows, and there's 1 in each row. Now, to the right of that equation on your paper, still the same number 3, isn't that it, 3? What's the multiplication equation we would write for this array? Write that multiplication equation down. All right. What is this multiplication equation, everybody?
4.
Oh, hold on. Wait, what?
4 times 2.
Okay. So, here you wrote, what are we on? First you wrote 4 times 1, and then you wrote 4 times 2. How could we use these two smaller multiplication equations to find the number of photos Nadia hung? Do you remember working on this yesterday? What did we do with these two equations? Remember, because we broke the array apart. What did we do with those two yesterday? Do you think we need to solve these?
Yes.
Okay, so we have to solve them, and then what do we do? Who remembers? After we solve those two multiplication equations, because they're broken apart, if they're broken apart, do they need to be put back together? What do you think, Amy?
They need to get put back together, so you add the one that equals 4 times 1, and then you add that one for the one that equals 4 times 2.
You are exactly right. She remembered correctly. Give her a round of applause. All right. So 4 times 1. I'm forgetting what that is. Who can help me out? 4 times 1. Raylan? What does 4 times 1 equal? 4. 4 times 2. Who can help me out there? Haley?
8.
Correct. It is 8. Okay, so using these two smaller arrays, Amy said that we have to do this. Oops, hold on. Sorry. My sleeve's writing. Remember looking at it this way yesterday? Do you remember that? So we said 4 times 1 is 4, plus 4 times 2 is 8, equals, what does 4 plus 8 equal? Or 8 plus 4 more. What does that equal? Everybody, what does it equal?
12.
Do you remember coming up with that answer yesterday? All right, so thinking back, one large array, like in the picture it, point to the picture it again. One large array was 4 times what?
30.
4 times 3. Two small arrays is 4 times, what's the first one they broke off? 4 times what?
1.
4 times 1 plus 4 times, what's in the other part that they broke off?
2.
2. All right, so if you struggle, skip counting by 3s, could you break it apart like they did here? Definitely. Just another strategy to help us with our multiplying. We're gonna skip that. Okay. Let's look at this next page. We have to find 5 times 3. Now, we might know it automatically, but they want us to draw a picture, so we need to do an array. That's the easiest way to do this next part. draw a picture and show a way to break apart the problem to find the product. So, how many rows will we have?
5.
5. Okay, so let's go 1. Oops, I have to have a writing utensil turned on to be able to actually write. So let's go 1, 2, 3, 4, 5. You can do squares if you'd rather, that's fine. How many are going to be in each row then?
3.
3 in each row. When we make an array, is it important to line up our objects? Yes, it is. Okay, we're not doing equal groups, friends. Let's do an array. It makes it easier to see. So I have 5 rows of 3 in each row. So how could I break this apart? Could I go like this? And like this? Or could I have done 1 over here and 2 over there? Does it really matter how I did it? Okay. So now, look at how you, can you sit up please? Look at how you broke that apart. What would be your multiplication equation for this broken part? And then what would be your multiplication equation for that broken part? Write those off to the side over here, your 2 different multiplication equations. Think about how many rows you have. That's your first number that you write. I thought I wrote that wrong. You ever do that? Yeah. Good job. Nice job. What all have you got going on here? Where's your other multiplication equation? Go with it.
I'm making it over here.
All right. So it doesn't matter if you did 1 first here or if you did the 2 first here. It's going to turn out the same way. But what would my multiplication equation be for this first group that I broke apart? How many are in each row? How many rows do I have, I mean? Everybody?
5.
And how many are in each row now?
2.
There are 2. Okay. What about the second part that I broke off?
5.
How many rows do I have?
5.
And how many are in each of those rows?
1.
Just 1, right? What do I do with that? Because I have it broken apart. It used to be all together, but I broke it apart. Now what do I need to do with it?
Put it back.
I have to put it back together. And to put it back together, what do I do with those? Add, subtract, multiply, divide. What do I need to do with these 2 problems once I have them figured out? Add them, subtract them, multiply them, divide them. Haley? I have to add them back together. Okay, so everybody, what's 5 times 2?
10.
And what is 5 times 1?
No,
Can you figure out what 10 plus 5 is then? Everybody?
15.
Okay. Everybody finished with that? All right, make an array to show this one. Cassie set up 9 tables with 3 chairs at each table for a party. Oh, hold on. They're having us solve this one differently. Sorry. So she has 9 tables. How many chairs are at this first table? 3. How many chairs are at this next table?
3.
How many chairs are at the third table?
3.
At the fourth table?
3.
Fifth table?
3.
Sixth table?
3.
Seventh?
3.
Eighth?
3.
Ninth?
3.
Okay, so we have to figure out how many chairs she used. So she has these 3 here, these 3 here, these 3 here, and so on. How could we do that? Sit up, please. How could we do that? In?
We can plus 3 9 times.
Okay, we could do repeated addition. What might be a little faster than repeated addition?
9 groups of 3.
9 groups of 3. What else could we do to help us solve this? Count by 3s 9 times.
We could make an array.
An array. Okay, I want you to solve this the easiest way it is for you to solve that problem. Because the idea is to not have to count by ones, right? Each time. Sorry, did I startle you? I startled myself. All right, how are we doing?
Good.
Good job. Write the multiplication equation that would go with that. With, what is it, problem 8. So first off, what's the multiplication equation that everybody wrote?
9 times 3.
And what did you get for that product?
27.
Oh, good job. 27 what though?
Chairs.
Exactly. So did you label your answer?
Yes.
How many of you did equal groups? Okay. Did anybody do an array? All right. Does it matter which way you did it? No, not at all. Okay. So looking here, which expressions, which means there's more than one right answer, can be used to find 8 times 3? So they're not splitting apart the 8. What are they splitting apart? The 3. They're breaking 3 apart. So both 8s here, did they split up the 3s?
No.
Did they split up 3 into 2 and 1?
Yes.
Oh, but look at their symbols here. 8 plus 2 times 8 plus 1? That's like saying 10 times 9. Is that the same thing?
No.
No, so what can we do with A? We can omit that one. What about this next one? 8 times 2 plus 8 times 1.
Yes.
Did they correctly break 3 apart?
Yes.
Okay. See if any of the other ones are true statements. Look carefully at the symbols that they're using. What about C? 8 times 1 plus 8 times 2.
Yes.
Yes. What about D? 8 times 1 times 8 times 2?
No.
So what can we do with it?
Omit it.
How about E?
No.
How many 3s are there?
8.
Ooh, is that a correct expression?
Yes.
Skip counting by 3s or counting by 3s 8 times. So could we circle it?
Yes.
Yes. Get that circled and then put it back in your folder.